Always on. AI assistants are marketed as effortless intelligence. They listen, learn, anticipate needs, and respond instantly, all without the user having to think about when or how they're working. Voice assistants, contextual suggestions, smart notifications, and proactive automation are now built directly into phones, laptops, wearables, cars, and home devices. On the surface, always-on AI feels like pure convenience. But beneath that smooth experience are trade-offs that tech companies rarely highlight. In 2026, these hidden trade-offs are shaping device design, costs, performance, and user trust in ways most people never see. The first trade-off is constant resource usage. Always-on AI assistants are never truly idle. Even when you are not interacting with them, they are monitoring context, managing wake words, analyzing patterns, and preparing to respond instantly. This requires continuous access to processing power, memory, and sensors. While each task is small, the cumulative load is significant. Devices must be designed to handle sustained background activity without overheating, slowing down, or draining batteries. That requirement changes everything from chip architecture to thermal design. Battery life is one of the most obvious consequences. Always-on AI forces designers to prioritize efficiency over peak capability. Specialized low-power AI cores are now necessary because general-purpose processors would drain batteries too quickly. This means more silicon dedicated to background tasks and less flexibility for other functions. In some cases, it also means limiting how powerful the AI assistant can be, simply to keep energy consumption under control. Another trade-off is performance predictability. When AI assistants are always running, they compete with foreground tasks for system resources. Even with careful scheduling, background AI can introduce small delays, memory pressure, or thermal buildup that affects active use. Tech companies now spend enormous effort ensuring that AI assistance does not interfere with basic responsiveness. The smoother the experience feels, the more engineering work is happening behind the scenes to hide these conflicts. Privacy is a deeper and more complex trade-off. Always-on assistants rely on continuous data awareness. Even when processing is done locally, devices must analyze audio, behavior, location patterns, and usage habits to function effectively. This raises difficult questions about what is being monitored, how long data is retained, and how transparently this is communicated to users. Designing AI to be helpful without feeling intrusive is one of the hardest problems tech firms face. To reduce privacy risk, many companies are shifting more AI processing on-device. But that creates another trade-off. Hardware cost. On-device AI requires more advanced chips, additional memory, and better power management. These costs are baked into devices whether or not users actively value the AI assistant. In effect, everyone pays for always-on AI, even if they barely use it. There is also a reliability trade-off. Always-on systems must operate across countless real-world scenarios. Background noise, accents, movement, sensor errors, and software conflicts all increase the chance of misinterpretation. A false activation or incorrect suggestion may seem minor, but repeated errors erode trust. Tech companies are learning that an assistant that is always available must also be extremely restrained to avoid becoming annoying or disruptive. Security adds another layer of complexity. An always-on assistant expands the attack surface of a device. Continuous listening systems, sensor access, and background services create more opportunities for exploitation if not carefully secured. This forces companies to invest heavily in isolation, encryption, and monitoring, increasing development and maintenance costs. The assistant may feel simple to use, but it is one of the most security-sensitive components in modern devices. There is also a trade-off in user autonomy. Always-on AI assistants increasingly make decisions automatically, adjusting settings, prioritizing notifications, or suggesting actions. While this reduces friction, it also reduces transparency. Users may not always understand why a device behaves a certain way. When systems optimize automatically, control shifts from explicit settings to inferred behavior. This can create discomfort, especially when the AI gets it wrong. From a design perspective, always-on AI AI changes how success is measured. It is no longer enough for an assistant to respond well when summoned. It must behave correctly thousands of times a day without being noticed. Silence, restraint, and accuracy matter more than clever responses. This forces companies to invest more in failure prevention than in flashy features. Cost structure is another hidden trade-off. Always-on AI increases long-term operating expenses. Even with on-device processing, updates, model improvements, and security maintenance continue for years. For cloud-assisted assistants, infrastructure costs grow with usage. This is one reason AI features are increasingly bundled rather than sold separately. The cost of always-on intelligence must be spread across the entire product ecosystem. There is also a cultural trade-off inside tech companies. Engineering teams must coordinate across hardware, software, AI research, privacy, legal, and support functions. Always-on AI cannot be built in isolation. Small design decisions can have wide-reaching consequences. This slows development and reduces experimentation, even as expectations for reliability rise. Importantly, these trade-offs do not mean always-on AI is a mistake. They explain why progress feels cautious rather than explosive. Tech firms are learning that intelligence embedded into daily life must be stable, efficient, and trustworthy before it can be ambitious. An assistant that occasionally amazes but often misbehaves is worse than one that quietly helps and rarely fails. In 2026, always-on AI assistants represent a shift in how technology fits into human routines. They are no longer tools we activate, but systems that coexist with us continuously. That requires compromise. Power must be conserved, performance must be predictable, privacy must be protected, errors must be rare. The hidden trade-offs behind always-on AI assistants reveal a simple truth. The more invisible technology becomes, the more complex it is to build responsibly. What feels effortless on the surface is supported by constant negotiation between convenience, cost, control, and trust. And that balance is now one of the most important challenges shaping the future of consumer tech.